Okay, here's some problems from section 2.4, and this is number 13, and the function was the absolute value of x. And remember, the absolute value of x is a piecewise function. It's equal to x when x is greater than or equal to 0, and it's equal to negative x when x is less than 0. I have to keep this in mind because we're not too sure what x is. So keep an open mind about this. And number 13, find the slope of the curve at the indicated point. We have two different points here. A, we want to find the slope at x equals 2. Well, remember, so A is x equals 2, so my point in my formula here for the slope, remember this is from page 90. This is the formula for the slope. It's a limit as h approaches 0. Okay, so A is going to be 2 in this formula. All right, now since 2 is positive, if we look up here at the absolute value of x, the absolute value of x just equals x when x is positive or equal to 0. So therefore f of x is just equal to x around 2, and we're near 2. So we're in the positive area of that absolute value. So I can put this in. So this is going to be my 2. So I just substitute in the formula. F of a plus h minus f of a over h equals. And then a is going to be 2, so I just put a 2 in. Now remember, the function is just the identity, so f of 2 plus h is just 2 plus h. See, f of x equals x, so it's just that. And then f of 2 is just 2. It's the identity. And then we can cancel. 2 minus 2 cancels out, so we have h over h. And the limit as, and that just simplifies to be 1. And the limit of 1 as h approaches 0 is just 1. So that's the slope. So the slope is 1. Okay, and then letter B. Okay, we want to find this at negative 3. So A is going to be negative 3. Since negative 3 is less than 0, then by the definition of my absolute value, when x is negative, then the absolute value of x equals negative x. So my function will be negative x near negative 3. All right, so again, I go through the same process. The limit as h approaches 0 of f of a plus h minus f of a over h. Now remember, this is the slope. So this is the definition of the slope. Okay? Should probably write down there that m equals for both these. Okay, this is my slope. M equals. And I'll write this over here also. So again, that's the slope. M equals the limit, and this is from page 91. This particular limit as h approaches 0. And then we substitute a is going to be negative 3. That will be the a. A is the point a in question is negative 3. So I substitute f negative 3, f of negative 3 plus h minus f of negative 3 over h. And remember, that's going to be negative x. Negative x. So negative whatever it is. So when I put this in, f of negative 3 plus h is just negative 3 plus h. Now there's a minus sign in our formula here. And then I've got f of negative 3 is just going to be negative that, so that's going to be negative. So that negative comes from there. And there's our negative 3 comes from our negative 3. So you got all these minus signs. One minus sign comes from the formula. One minus sign comes from the absolute value. This actually up here. That's where that minus sign comes from. And then one minus sign comes from the data. Okay, so we got a lot of minuses there, or negative signs. Okay, so this just becomes, if I multiply this out, this is negative 3. Negative times a negative is positive, so it's positive 3 minus h. And a negative times a negative is a positive, times a negative is a negative over h. And the 3's cancel, so I got negative h over h, which is negative 1, and the limit as h approaches 0 of negative 1 is just negative 1. It's a constant, so it's just that negative 1. So that's my slope. So the slope for B is negative 1, the slope for A is 1. Okay, I hope that makes it clear. And try to go through these so you thoroughly understand these problems because they're very important.